Welcome to clickmyproject.com.
This is our title, mining frequent pattern without candidate generation, a frequent pattern tree approach. This is a project abstract. In this existing parallel mining algorithm for frequent item set, lack of mechanism that enables automatic parallelization, load balancing, data distributions, and fault tolerance on large clusters. As a solution to this problem, we designed a parallel frequent item set mining algorithm called Fidoop using the MapReduce programming model. To achieve compressed data storage and avoid building conditional patterns bases, Fidoop process cooperates the frequent item ultrasonic tree rather than the conventional FP trees. In Fidoop, the MapReduce jobs are implemented to complete the mining task. In crucial third MapReduce job, the mappers independently decomposes items that reduces performs combinations operations by constructing small ultrametric trees and the actual mining of these trees separately. We implement Fidoop on our in-house Hadoop clusters. We shows that a Fidoop on a clusters is sensitive to the data-centric distributions and dimensions because item sets with a different length have different decompositions and construction costs. To improve Fidoop performances, we develop a workload balance metric to measure load balance across the clusters computing nodes. We develop Fidoop HT and extensions of Fidoop to speed up the mining performances for the high dimensional data analysis. Extensive experiments using real-world spectral data demonstrations that our proposed solutions is efficient and scalable. Item set mining is a core problem in association rule mining. Sequence mining under the speeding up the process of FIM. Frequent item mining is crucial and in, in indispensable because frequent item mining consumptions accounts for a significant portions of mining time due to its high consumptions and the input-output intensity. When dataset in modern data mining applications became extensively large sequential FIM algorithms running on a single machine suffers from the performance deteriorations. To address these issues, we investigate how to perform frequent item mining using MapReduce, a widely adopted program mining tools model for proposing big data by exploiting the parallelism among the computation nodes of a cluster. We show how to distribute a large dataset over the clusters to balance a load across all cluster nodes, thereby optimizing the performance of parallel frequent item mining. Frequent item set mining algorithms can be divided into two categories, namely a priori and FP growth schemes. A priori is a classic algorithm using the generations and the test process that generates a large numbers of candidates item set. A priori has to repeatedly scan an entire database to reduce the time required for scanning databases. Most previously developed parallel frequent item mining algorithm we built upon the a priori algorithm. Unfortunately, in a priori parallel frequent mining algorithm, each process has a number of candidates item sets without processors. Therefore, a priori parallel frequent item mining solution suffers potentially problem of high input-output and synchronization overhead, which makes it strenuously to scale up these parallel algorithms. The scalability problem has been addressed by the implementations of the handful of FP growth like parallel frequent mining algorithm. A major disadvantage of frequent pattern growth algorithm however lies in the infeasibility to construct in memory FP tree to accommodate large scalable database. This problem becomes more pronounced when it comes as a massive and multi-dimensional databases. And this is our data flow. First we'll be starting, then dataset selection will be carried out, then the dataset will be uploading into your databases, then pre-processing techniques will be carried out. In this pre-processing technique, we will be carrying out the process like removing the unwanted data and the irrelevant data and the data which has been repeated and the data which has been missing a values. Then error correction of a free dataset will be carried out. Then analysis informations will be carried out for the data which has been get loaded into the databases. Then partition of the data will be carried out for a frequent item mining, and the entire data will be get partitioned into an attribute manner. Then the trusted value will be founded for get the frequent mining. Then the clustering algorithm will be used for getting the data from the entire database. Then the support and free conference level will be get founded. Then the frequent item sets will be get enlarged. Then after that, the merging and results will be calculated. And then this is an end process. This is a project. Just right click on our home and click on our run file. we'll be getting a home screen. Just click on here. We'll be getting a screen like this. In this, choosing a data set. I'll be choosing a data set online retail and open and load. Data set loaded successfully. This is our entire data set. And next, and this will be pre-process successfully. Loading to information director. Next process will be uploading into an STFS process. While it's being uploaded successfully, map and reduce. Process will be get reduced, map and reduced like this. Map and reduce completed. Next process will be calculating a C4.5 predictions, entropy, gain, and result is being calculated. In this prediction 1, I can view that. On prediction 2, I can able to see a difference in this. For prediction 2, I can able to see a quantity differences. In this, I will be getting a frequent mining. This is a frequent mining for particular customers. Frequent mining for particular customers. The graph and this graph being a prediction and accuracy rate, which is going to tell us the performance of a frequent item mining. Thank you.